All right, so part two, equivalent representations. We're going to start out with some identities for sine and cosine. Here we go.
Two additional identities that are important are the sum identities for sine and cosine. Given any two angles, alpha and beta, sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta, and cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta.
All right, fantastic. So when we use these things, okay, we have to memorize these things because we don't get like a little cheat sheet on the AP pre-calc exam. All right, because this is a real math class, we have to memorize this. Now, there's a couple things that I want you to kind of like look into to try to help us memorize these. So sine is more well-behaved than cosine. And what I mean by that is if we have addition here, guess what? We have addition there. And if we have subtraction here, guess what? We have subtraction there. And so the sine alpha plus beta, we're still going to have sine and cosine. So we're going to have sine alpha, cosine beta, and then cosine alpha, sine beta. However, cosine's kind of naughty. And it works the same way with like half angles. And we're not going to talk about that at this point in time, but you'll get to it in Calc 2 and maybe here. But really, cosine, if we have addition, guess what we're going to have? We're going to have subtraction. All right, it does the opposite. All right, and so on these, we have cosines that group together first, and then the opposite sign, and then the sines group together second. Okay, so again, now moving on to the double angle identities. And so this is where I kind of need you to kind of just memorize a little bit. And so sine of 2 theta is equal to 2 sine theta cosine theta. All right, and so there's our double angle, and it actually comes up a decent amount on A team. All right, not a lot, but anyway. All right, and then this one, it has 3, and so cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And that's the one I want you to memorize. That one right there is the one I want you to memorize. Now, the other two are derived from that one. And I kind of want to talk about that one right there. And so what is that trig function that you guys needed to remember? Sine squared plus cosine squared was equal to what? 1. And so this is how it's used. And so what could I replace cosine squared with? Cosine squared could be replaced with what? 1 minus sine squared. So if I replace the cosine squared with 1 minus sine squared theta, and then I still have a minus sine squared theta, then I end up having 1 minus what? 2 sine squared theta. And see how those two are the same now. All right, that's how that one's derived. And if we did it the other way, what is sine squared actually? If I go back up here, what is sine squared really? 1 minus cosine squared. And so now I'd have cosine squared minus the quantity 1 minus cosine squared. And then what would I highly suggest you do with that little negative thing? Distribute it. So now we got a negative right there and a positive there. And so then how many cosine squareds do I have? 2. I have 2 cosine squared theta minus 1. And that's where this one comes from. All right. But I would highly recommend you kind of memorize this first one. All right, and then if you needed to, we can get those other two by using our trig identity. All right, let's look at example 4. And so on this example 4, we need an equivalent expression of 2 sine of pi over 14 cosine of pi over 14. And so which one does that look like? I have a 2 sine and then a cosine. What does that one look like? It looks like this right here. And so this is going to be a what? So this is in the form of like 2 sine x cosine x, yes? And that's the same thing as saying sine of 2x. Everybody follow that? And so what the heck is x? Pi over 14. And so then all I do is substitute in pi over 14. So now I have sine of 2 times pi over 14. And so 2 times pi over 14 is really what? Pi over 7. All right. And so that is equivalent to this. All right. And so if we were to use our calculator, these would be synonymous. All right. It's just a different way to look at it. All right, so in example 5, we need to figure out what's equivalent to 4 cosine of 2x. Now, on our cosine of 2x, what do we use for that? You guys are more than welcome to look at your notes at this point. Cosine of 2x is equivalent to what? Cosine squared theta minus sine squared theta. And so this is the same thing as 4 times cosine squared x minus sine squared x. All right. Now, do any of my answer choices match up with that one? No, they don't. So we need to manipulate it a little bit further. And so what could we change? Could we change cosine squared? Yes. What could we change cosine squared to? 1 minus sine squared. And so let's try it. And so now we have 4 times 1 minus sine squared. And then I still have minus sine squared, which goes to what? 4 times 1 minus 2 sine squared. Now, if I were to distribute that 4, does it match up with anything? Say no. No, it doesn't. It doesn't match up with anything. So now let's go a different way to Tampa. And so now let's figure out what sine squared is. And so now I'm going to change my sine squared. So now I'm going to have 4 times cosine squared minus, what is sine squared equivalent to? 1 minus cosine squared. And what would I highly suggest you do right here? Distribute the negative. All right. And so now I'd end up with 4 times, how many cosine squareds do I have? 2. I have 2 cosine squared. And then minus 1. Now, if I were to distribute that 4, does that match up with any of them? Yes. Which one does that match up with? C. It matches up with C. All right. All right. So on example 6, I have cosine of pi over 8, cosine pi over 6 minus sine of pi over 8, sine of pi over 6. Is this a cosine or a sine addition or subtraction? It's a cosine. How did we know it was going to be a cosine? Because I have the 2 together. That's how I want you to look at this. And so this is definitely a cosine. And now, is this going to be my cosine that's adding the 2 together or subtracting the 2? It's going to add them. Why is it going to add them? Because it's subtraction. And so on this one, I'd end up with cosine of pi over 8 and then plus pi over 16. Right? And so what do I need now? So I look for that answer. It's not there. So what do I need now? Common denominators. All right. So how should I think of pi over 8? 2 pi over 16. So I have 2 pi over 16 plus pi over 16, which is how much? 3 pi over 16. Sure.
The figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of P are 5 and 12. Which is the value of sine 2 theta?
All right, so now we need to find sine of 2 theta. And so on this one, do I know what theta is? No, I don't. I just know where it's kind of graphed, but I don't know what theta actually is. So this is where we need to use our double angle. And so what does sine of 2 theta is equivalent to? 2 sine theta and times cosine theta. All right, we just have to recognize that. All right, and so eventually we're going to need that memorized. Right now you can look at your notes for all I care. All right, and so now let's kind of look at our little triangle. Now I don't like it drawn there, and so I'm going to kind of rewrite it. And so my x value is what? 5. And then my y value is 12. And then my hypotenuse is, it literally tells us? 13. All right, because my radius is going to be the same all the way around. All right. And so who is that princess that I know about? Sokato. There we go. All right. And so now when I solve these things, I end up having sine. And so sine is what? Opposite over hypotenuse. So my opposite is what? 12. And then my hypotenuse is 13. And then the cosine of theta. So cosine is what? The adjacent over the hypotenuse. So my adjacent is 5, and then my hypotenuse is 13. And so now we just have to do a little bit of math. 2 times 5 is 10. 10 times 12 is 120. And then 13 times 13 is 169. All right. All right. Pretty good? Cool. Let's do it again.
Interruption, teachers.
Alright. The figure showed two circles centered at the origin with angle measures of A and B.
Alpha.
Alpha and beta, respectively, in standard position. The terminal ray of angle alpha intersects the circle at point P, and the terminal ray of angle beta intersects the circle at point Q. The coordinates of P are -5 and square root of 11, and the coordinates of Q are 2 and square root of 5.
All right. Love it. Before we get on to these examples, I want to kind of draw our little triangles. And so what's my x value of my alpha? -5. And so I kind of like to look at it right there. And so then my y value would be what? Square root of 11. And then my hypotenuse is 6. All right. If it didn't give us our radius, what could we have used? Pythagorean theorem. All right. But it gave it to us, so we might as well use it. All right. And so now let's look at our beta triangle. And so my x value is what? 2. And then my y value is square root of 5. And then my hypotenuse is 3. Love it. All right, and so now let's look at part A. And so this one says cosine of 2 alpha. And so this is a double angle. And so now I kind of need to use one of them. And so we can go back and look at our notes. It's got 3 different options. However, I would suggest using the first one. And so what was that first one? Cosine squared alpha and then minus sine squared alpha. All right. I would highly recommend you use that first one because it's going to give you a common denominator each time. All right, and you don't need to manipulate it to get to another one. All right, and so now let's look at our alpha triangle. And so on our alpha triangle, what do I need to find? The what? The cosine of it. And so what is the cosine of this alpha triangle? So what is my adjacent? -5 over 6. And now I'm going to square it. All right. And then minus the sine of my alpha triangle. So what's my sine? Square root of 11 over 6. And then I'm going to square it. All right. And so what is -5, 6 squared? It's not negative anymore. It's going to be positive 25 over 36. And then minus, what is square root 11 over 6 squared? 11 over 36. And so then I do a little bit of math. 25 minus 11 is 14 over 36. In pre-calc, we need to simplify. And so now we'd end up with what? 7 over 18. Now let's look at this next one. So now we have sine of alpha plus beta. So it's a sine, and so let's kind of rewrite this one. And so when we have a sine alpha plus beta, does it kind of match up? Yes, it sure does. And so this is the same thing as saying sine alpha and then cosine of beta, and then a plus or a minus. Plus, it's well behaved. And then plus, and then cosine of alpha, and then sine of beta. All right. All right, now let's play. And so now if I need to do the sine of alpha, I look at my alpha triangle. All right, so my red one, I'm going to try to color code this for you. And so what is the sine of that triangle? Square root of 11 over 6. And then we're going to find the cosine of my beta triangle. So now I need to look at my blue one. And so then what's the cosine of that beta triangle? 2/3. And then plus, now I need to find the cosine of my alpha triangle. So now I'm going back to my red one. And so what is the cosine of my alpha triangle? -5 over 6. And then I need to do the what? The sine of my beta triangle. So what's the sine of my beta triangle? Square root of 5 over 3. All right, so now let's do a little bit of math. Square root 11 times 2 is just what? 2 square root 11. And then 3 times 6 is 18 plus negative 5 times square root 5 is just negative 5 square root 5 over 18. So again, it gave us a common denominator, so we're going to go one more step. And so now we'd end up with 2 square root 11 minus 5 square root 5 all over 18. All right. All right, now let's look at part C. So on part C, it says find cosine of alpha minus beta. On this one, we have a cosine, and so cosines, they go together. And so now I'd end up with what? Cosine of alpha and then cosine of beta. Now it says minus, so what do we know it's going to be? It's going to be plus. It does the opposite. And so now we'd end up with sine of alpha and then what? Sine of beta. All right. All right, and so now let's keep going. So now what's the cosine of alpha? So I need to look at my alpha triangle again. And so what's the cosine of my alpha? Negative 5/6. And then the cosine of my beta. So what's the cosine of my beta? 2/3. And then plus, now I need to do the sine of alpha. I guess that should have been in blue. And then the sine of alpha, which would be what? Square root 11 over 6, and then the sine of my beta, and so we'd end up with square root of 5 over 3. And so now, again, if you notice, what's going to be the common denominator again? 18. So let's just skip a step. It's going to be all over 18. And so what's in my numerator now? Negative 10 plus what? Square root of 55. All right, square root of 11 times square root of 5 is square root of 55. And then it's all over 18.